Welcome Pure Maths 1 students to week 5 of our maintenance program. Hope you had a chance to do this in advance of the video, and that most of it you will have managed to get by yourselves, but if not, hopefully this video will be helpful to you. So we're still just looking at quadratics and functions. I think next week we're going to start including coordinate geometry in our maintenance as well. So the first one here, find the set of values for k for which the line y equals kx minus 4 intersects the curve y equals x squared minus 2x at two distinct points. So what you're thinking of here, let's draw a quick diagram. So let's say we've got a curve like this. That's this bit. And there's a line. Now a line, you can imagine, you could have a line that goes like this and it will never touch. Or you might have a line that touches at just one point, let's say like that, okay? Or you could have a line that touches at more than 1 point or at 2 points, so something like this, okay? And the k will tell you the gradient, and the minus 4, so it crosses here at minus 4. Obviously I don't think I definitely haven't drawn the graph correctly. If I was to draw it correctly, we're looking at something like this, isn't it? Because we could factorize the second thing here, x into x minus 2. So we're going to have a crossing point here and a crossing point here. So this is the curve, and then you'd have a line at minus 4 here, and you want and you want a gradient on it. So it's going to be reasonably steep if you're going to have two crossing points. Otherwise, if it's too shallow, you're going to get none. Okay, now anyway, that's just a visual of what we're doing. So what I'm going to do is I'm going to make an equation. I want to know where the line, which is kx minus 4, crosses or meets or is equal to the curve. Then I'm going to pull everything across to the left hand side. So I'm going to get a quadratic like this. Now, I want my discriminant in this case, which is b squared minus 4ac, to be equal to, greater than or equal to, greater than, that's horrific, isn't it? Let's get rid of that. Oh dear. Learn to use this, Mr. K. Okay. Greater than or equal to 0 to have two meeting points. So what we're going to do, b squared, so that's our minus 2 minus k. You might be thinking, how the heck did he get that? Well, I could rewrite this as x squared plus x into minus 2 minus k, right? I've just factorized that, plus 4. Okay, so that's me b squared, and then minus 4ac. 4 times 1, and then c is 4. And I want this to be greater than 0. Now, when we expand this, we're going to get 4. Then we're going to get plus 4k plus k squared minus 16, and we want this to be greater than 0. So I could rewrite it as k squared plus 4k minus 12 is greater than 0, and then I could perhaps factorize that. Yep. So k plus 6, k minus 2. Now, let's look at this. If I sketch this, I've got a point here at minus 6, a point here at 2. And I want to know where it's greater than 0. And you can see here and here. So say k is less than 6. Minus 6, or k is greater than 2. Alright, so there we go. I'm going to give myself a bit more room over here. Okay, so this next one we're solving an equation here. It's a bit of algebra. My first step is I want to make a common denominator, so I'm going to cross multiply. So it'll be 2x plus into x plus 2 plus 3x all over x into x plus 2. Is equal to 1. So what you see, I've times this whole fraction by x plus 2, and I've times this whole fraction. Sorry, the last one I times by x over plus 2 over x plus 2, and this one, the second fraction, I'm timesing by x over x. Now, there we go. Next line, well, the numerator I can perhaps do that too. And I've got this. I'll just leave this as it is for now, and that's equal to 1. Next line, I'm going to bring the denominator across. Actually, I could say, what could I say there? 2x plus 3x is 5x, couldn't I? So I could go 5x plus 4 is equal to x bracket x plus 2. And that will give me, let's just expand that bracket out. 5x plus 4 is equal to x squared plus 2x. I'm going to bring everything across to the right-hand side. So I would get 2x minus 5x, which is negative 3x minus 4. And then I'm just going to factorize that. So x minus 4 bracket x plus 1 bracket equals 0. So x is equal to 4 or minus 1. And that'll be our final answer. Okay. Next one we're going to solve by completing the square and find the positions of the turning point. So here is the equation that we're completing the square for. So my first step is to write, let's not write with the highlighter. So x plus 2 all squared subtract 4. So that's this bit here, rewritten. And then I've got that minus 7 at the end. Now let's just gather everything together. X plus 2. Oh, and that's meant to equal 0. Minus 4 minus 7, which is minus 11, is equal to 0. Now, straight away, I know the coordinates of my turning point. So my turning point is at, now, we look at this bit here. To get the minimum point of a positive quadratic, we're going to have a negative 2 for our x value, because to make the lowest value possible, you want to get this bracket here equal to 0, because 0 squared is 0, and then that will give you the minimum point, because anything else that you square is going to be a positive, which means the value will end up being higher. So this gives us a minimum point, and then when you've got a negative 2 there, the y result will therefore be minus 11. Okay, so you get a negative 11 there. Okay, so that's our turning point at neg 2, neg 11. Okay, now, what are we trying to do? Oh, we are trying to solve by complete the square. Okay, so my next point move would be to move that 11 across to the other side. Then I'm going to take the square root of both sides. So I'll get plus or minus the square root of 11. And then so x is equal to negative 2 plus or minus the square root of 11. And those are our two solutions. There we go. That's fairly easy. Okay, so next one, we are trying to solve the simultaneous equations. Okay, so it's nice and easy. We've got y equals something, y equals something. So we just go x squared equals 6 minus x, because both of those are what y is equal to. Bring everything across to the right-hand side, and then solve the equation. Looks like we can factorize. Yeah, so it's x plus 3, x minus 2. And what does this give us? So equals to 0, and that means that x is equal to minus 3 or positive 2. And we're good. Now, we also need to find y. Therefore, y equals, and you can just chuck it into here. So 6 minus 3 is 9. Or, what do we say? 6 minus 2, so 4. And the coordinate pairs would therefore be, where they meet is 9 minus, comma minus 3. Let's put the x coordinate first, shall we? Negative 3, comma 9, or 2, comma 4. Okay, that brings us to the function section of this week's maintenance. And, okay, let's see how we go. We're going to find the range of the function 2 to the power of something for x is less than or equal to 2. Okay, well, let's just think about it. Let's put in our x values and then our fx values. If you think about it, we'll start with 2 because it's got to be less than 2. So when we've got that, we get 2 to the power of 2 is 4. We've got 1. 2 to the power of 1 is 2. 0. 2 to the power of 1 is 1. Oh, sorry, 2 to the power of 0 is 1. Wake up, Mr. King. And we can go to negatives as well. 2 to the power of negative 1 is 1/2. And so on and so forth. So you see that as we go further into the negatives, we'll get a very, very small number approaching 0 but never reaching 0. So I think we'd write 0 is less than fx is less than or equal to 4, because we could get a 4 here. Okay, I think that's pretty much solved that one. Now, the next one. What have we got here? We have... Why is this not working? There we go. We have fx is x squared minus 2x plus 4. X is a member of the set of real numbers. Find the set of values for which fx is greater than or equal to 7. So what we do is we go this. Greater than or equal to 7. I'm going to pull that 7 across to the let's see. I'm just wondering, there's another way of doing it that I just thought of, but I'll go ahead with this. So if I pull this across, I should get that. X squared minus 2x minus 3 is greater than or equal to 0. Now, looks to me like we can actually factorize that like this. Yeah. Okay. So if I quickly sketch this, I know I've got a root here at 3, and I've got a root here at minus 1, and it's going to be looking something like this. Now I want where it's greater than 0. So it's greater than 0 on that side of the minus 1, and on this side here, greater than or equal to. So we would say x is less than or equal to minus 1, and x is greater than or equal to 3. Okay. The next one we're completing the square to figure out the range of f. So I'm looking at this, and I'm going to complete the square. So x minus 1, because I halve that minus 2x, I square that, I subtract the 1. So what I've got now, at this point, here, is equal to here. Now, what we're going to do here is we're going to add that 4 on the end and simplify it. So that gets us to plus 3. And therefore, the TP, the turning point, is at 1, 3. So, is that right? Well, that doesn't look right to me. Yes, no, that is correct. So that means that the range of it is fx is greater than or equal to 3. Alright, the last one that we're going to do today is we've got a function fx. So here's our function fx, it's x squared. That's fx. Now, what happens if we do f minus x? Okay, well, we'd put the minus x in for the values of x and square them. And so what you'd find in this particular case is we just get a mirror image like that. Oh, not a very good mirror image, by the way I've drawn it, but you get that. Okay. And, oh sorry, no you wouldn't. Think carefully, Mr. K. Sorry guys, that is not what you get. So I want you just think about this. If you put in a minus of the x value. So let's just say we've got, here's our x values. Let's go minus 1, 0, 1, and let's do fx. All right. Well, minus 1 squared is 1, 0 squared is 0, 1 squared is 1. Now let's do f minus x. Okay. So we take this and we minus it. So minus 1 is 1. 1 squared is 1. 0, 0. We take this and we minus it. Minus 1 squared, 1. Okay, so it's exactly the same. So this is fx and f minus x. Okay. Remember what it does when you put in a negative here is it's a mirror image across the y-axis, and since this turns it's a mirror image of itself on the y-axis, it doesn't make any difference. Now this one here, this next one, this is what I was thinking of before. Here you take your fx value and then you times it by minus 1, so this would be a reflection across the x-axis. Alright team, I hope that makes sense. I hope you're feeling more confident about this kind of stuff. Feel free to ask questions in the comments or on ThinkWave. Talk to you soon.